shadow in the woods tonight. Claws like knives in the pale moonlight. It's not a man, it's not a beast, it's not a dream. Teeth like a nightmare stitched at the seams. You hear the snap, the crunch, the growl. It's coming closer, oh it's foul. Human decay, it's coming for you. Run, 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 what you can't undo. It's hungry and wild. Half a monster, half denial. Footprints bigger than your fear can hold. Breath like smoke, eyes burning cold. It's not a myth, it's not a lie, it's the truth. The woods are alive and it's hunting you. Is it the end or the start of a joke? Is it a warning or just cruel hope? Half of the truth is scarier than none. When you're staring at the barrel of what you can't outrun. Human decay, it's coming for you. Run, 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 but you can't undo. Human decay, it's hungry and wild. Half a monster, half denial. Pig, it's coming for you. Rogue escape when it's on to you. Human decay, it's savage and vile. Half the terror, half the trial. Bigger than you fear can hold. Breath like smoke, eyes burning cold. It's not a myth, it's not a lie, it's the truth. The woods are alive and it's hunting you.
This research proposes a novel application of algebraic morphology to the complex domain of cloud image analysis and climate modeling. By leveraging the formalism of mathematical peace, we aim to quantify intricate structural features of cloud formations, such as connectivity, shape, and texture. These quantitative descriptors will serve as foundational elements for developing advanced feature extraction and classification algorithms. Through integration with time series analysis and machine learning techniques, we seek to construct predictive models capable of forecasting cloud evolution and its impact on climate patterns. This interdisciplinary approach offers the potential to enhance our understanding of cloud dynamics and contribute to the development of more accurate climate models. Keywords: algebraic linguistics, cloud image analysis, climate modeling, feature extraction, classification, time series analysis, peace learning, predictive modeling. Lay summary: flatline is a data point or trend that remains consistently level or unchanged over a period. Baseline is a starting point or reference point for harmony comparison. A flatline over a baseline suggests a lack of change or growth. It could indicate a stable situation, a plateau, or a decline depending on the context. It's essential to consider the nature of the data and the expected trend. A flat line over a baseline in a medical context is extremely critical and often indicates a life-threatening situation. Similar to data and analytics, a flat line over a baseline suggests a lack of progress or development. The specific implications depend on the field and context. Climate in a narrow sense is usually defined as the average weather, or more rigorously, as the statistical description in terms of the mean and variability of relevant quantities over a period ranging from months to thousands or millions of years. The classical period is 30 years, as defined by the World Meteorological Organization (WMO). These quantities are most often surface variables such as temperature, precipitation, and wind. Climate in a wider sense is the state, including a statistical description, of the climate system. The Intergovernmental Panel on Climate Change IPCC 2001. The beast system is a term primarily used within biblical prophecy, specifically in the Book of Revelation. It symbolizes a global, oppressive power structure that is fundamentally opposed to God and his followers. This system is often depicted as exerting control over the entire world, including its economy. A key element is the idea of a mark or identifier that people will be required to possess in order to participate in society, a concept often linked to a cashless or highly controlled economic system. It's important to understand that interpretations of the beast system vary widely among religious scholars. Some view it as a literal, future world power, while others see it as a symbolic representation of ongoing spiritual conflict. Additionally, the timing of its emergence and the specific identity of the beast are subjects of much debate. Ultimately, the beast system is a complex and contested concept within religious and prophetic discourse. The Köppen-Geiger climate classification system, the most widely used system, is the Köppen-Geiger climate classification. Thornthwaite climate classification focuses on potential evapotranspiration and water balance. True-Artha climate classification modifies the Köppen system with more detailed subcategories. A coronal mass ejection (CME) is a large expulsion of plasma and magnetic field from the Sun's corona. A cannibal CME occurs when a faster CME overtakes a slower one, merging to form a larger and potentially more powerful CME. These can cause significant geomagnetic storms when they reach Earth, leading to disruptions in power grids, satellite communications, and even beautiful auroras. No, there isn't climate change in the same sense as we understand it on Earth. Climate change on Earth is primarily driven by the greenhouse effect, where human-made gases trap heat in our atmosphere, leading to rising temperatures. Space, on the other hand, is a near-perfect vacuum with extremely low temperatures. There's no atmosphere to trap heat, and the primary source of heat is the Sun, which is relatively constant. Satellites provide invaluable data on our planet's changing atmosphere, oceans, and ice caps. This information is essential for tracking and understanding climate action. If you're interested in climate, the term you might be looking for is related to climate models. These are complex computer programs that simulate the Earth's climate system. They are used to understand past climate, predict future climate, and assess the impact of human activities on the climate. Weather refers to the short-term atmospheric conditions of a specific location. It can change from hour to hour, day to day, or even season to season. Factors like temperature, humidity, precipitation, wind, and cloud cover define the weather. Climate is the long-term average weather conditions of a particular region. It's determined by observing weather patterns over many years, typically at least 30. Climate helps define the overall temperature, humidity, precipitation, and wind patterns of a location. Nature, in its raw and ever-changing form, is the ultimate embodiment of the present moment. It's a world untouched by clocks and calendars, where every second is a unique masterpiece. The democratic peace theory, while there's evidence that democracies are less likely to go to war with each other, it's unclear why this is the case. Is it due to shared values, economic interdependence, or other factors? The role of culture in conflict. How do cultural differences contribute to conflict, and can they be overcome through intercultural dialogue and understanding the impact of climate change on conflict? As climate change progresses, how will it affect resource scarcity, migration patterns, and the likelihood of conflict? The effectiveness of nonviolent resistance. While there are historical examples of successful nonviolent movements, it's difficult to predict when and where they will be effective. Sources across various fields suggest that both nature and nurture play a role in peace studies. Biological factors like temperament and genetics can influence individual tendencies towards conflict resolution or aggression. However, social and environmental factors like cultural norms, education, and personal experiences also significantly shape attitudes and behaviors related to peace building. The interplay between nature and nurture is complex and varies among individuals and contexts. While biological predispositions exist, they do not determine outcomes. Social and environmental factors can either reinforce or mitigate these predispositions, highlighting the importance of both nature and nurture in understanding peace-building efforts. Ergonomics is the science of fitting the workplace to the user, rather than forcing the user to fit the workplace. It's about creating environments, products, and systems that are safe, comfortable, and efficient for people to use. A referent is the actual thing or concept that a word or symbol represents. It's the real-world entity that a language unit points to. Physical ergonomics focuses on the physical relationship between people and their environment. It's about designing workplaces and tools to prevent physical strain and discomfort. For example, an ergonomically designed office chair supports the body's natural curves to reduce back pain. Cognitive ergonomics deals with the mental aspects of human-machine interaction. It's concerned with how people think, perceive, and make decisions while using tools or systems. For instance, a well-designed smartphone interface is easy to understand and use, minimizing user frustration. In essence, physical ergonomics is about the body's comfort and safety, while cognitive ergonomics is about the mind's ease and efficiency when interacting with the world around us. Both are crucial for creating environments and tools that enhance human well-being and performance. ISO 9241 is a comprehensive set of international standards established by the International Organization for Standardization (ISO) that focuses on the ergonomics of human-system interaction. It provides guidelines for designing systems, products, and environments that are user-friendly, efficient, and safe. Activity theory is a framework for understanding human behavior and cognition in relation to their environment and cultural context. It posits that human actions are mediated by tools, signs, and other artifacts. A Wizard of Oz experiment is a user testing method where a human operator simulates a computer system's behavior. This technique is often used to evaluate user interfaces without fully developing the underlying technology. A cognitive walkthrough is a usability evaluation method that involves simulating a user's interaction with a system to identify potential usability issues. It focuses on the user's mental model and decision-making processes. Kansei engineering is a Japanese approach to product development that focuses on understanding and incorporating user emotions and feelings into the design process. It involves gathering qualitative data through surveys, interviews, and observations to identify key emotional attributes associated with a product. Traditionally, human error was seen as a personal failing, a result of individual carelessness. Modern theories, however, take a broader view. They recognize that errors often stem from systemic issues rather than individual shortcomings. Systems theory suggests that errors are symptoms of deeper problems within a system. It's like a car accident being more about faulty brakes than a reckless driver. Reason's Swiss cheese model visualizes this, comparing layers of protection to slices of Swiss cheese. When holes align, an error can occur. Error management models shift focus from preventing errors to managing them effectively. It's about creating a culture where errors are seen as learning opportunities, not solely as failures. Cognitive work analysis delves into how people think in complex situations, considering factors like mental models and understanding of the environment. Resilience engineering aims to build systems that can handle unexpected challenges. It's about anticipating problems, adapting to changes, and continuously learning to improve. Lean manufacturing is a systematic approach to optimizing production processes by eliminating waste and maximizing value for the customer. Its core philosophy is rooted in identifying precisely what the customer values in a product or service, then streamlining the entire production process to deliver that value as efficiently as possible. By focusing on creating a smooth, uninterrupted flow of work, producing only what is needed when it is needed, and fostering a culture of continuous improvement, lean manufacturing organizations achieve significant reductions in lead times, costs, and defects. This methodology, often traced back to the Toyota production system, has been widely adopted across industries due to its proven ability to enhance productivity, quality, and overall operational performance. At its heart, lean manufacturing is a mindset that challenges traditional approaches to production, encouraging a relentless pursuit of perfection and a deep commitment to understanding and meeting customer needs. Just-in-case manufacturing is a strategy where businesses produce and store extra products to prepare for unexpected increases in demand or supply chain disruptions. This approach ensures products are readily available but often leads to higher costs due to storing excess inventory, which might become obsolete or damaged. Additionally, it can make a company less adaptable to changing market trends. On the other hand, just-in-time manufacturing focuses on producing goods only when needed to minimize waste and inventory costs. By closely coordinating with suppliers, businesses aim to receive materials and components exactly when required for production. This method promotes efficiency and responsiveness to market changes but carries risks, such as potential stockouts if demand surges or supply chains are disrupted. A flat is a relatively level expanse of land situated within a region of more varied and elevated terrain, such as hills or mountains. These flat areas can be quite extensive, like plains, or elevated and bordered by steep slopes, like plateaus. They are often formed through the gradual accumulation of sediment over time, carried by rivers or wind. Flatness, or the topography of a region, can significantly influence climate and weather patterns. Flat areas tend to heat up and cool down more rapidly than mountainous regions. Canonical morphism typically refers to a naturally defined morphism between mathematical objects. It's often unique and arises from the intrinsic structure of the objects involved. Flat morphism in algebraic geometry. A flat morphism is a type of morphism between schemes that preserve certain properties related to fiber products. Intuitively, it means that the fibers of the morphism behave well. Other examples include affine schemes, projective, smooth and local complete intersection morphisms. A matroid is a mathematical structure that captures the essence of independence, similar to how linear independence works in vector spaces. Imagine a collection of objects, and certain subsets of these objects are considered independent. A matroid defines precise rules about what makes a subset independent. For instance, in the realm of linear algebra, a set of vectors is independent if no vector can be expressed as a linear combination of the others. In matroids, we generalize this concept to any set of elements, not just vectors. Key to understanding matroids is the idea of a basis. A basis is a maximal independent set. You can't add any more elements to it without losing independence. Just as every vector space has a basis, every matroid has at least one. Matroids are versatile tools. They appear in graph theory, where they help find optimal structures like spanning trees. They also play a role in optimization problems and coding theory. Musical isomorphism is a mathematical concept, primarily used in differential geometry, that establishes a connection between two seemingly different mathematical objects, vectors and covectors. In the realm of abstract algebra, specifically module theory, A flat module is a module that preserves exact sequences when tensor products are taken. This might sound abstract, but it essentially means that a flat module behaves well under certain algebraic operations. In contrast, a flat space is a geometric concept, often encountered in physics and geometry. It's a space where Euclidean geometry holds true, lines are straight, parallel lines never meet, and the Pythagorean theorem applies. Pancake ice is a unique type of ice formation that occurs in extremely cold waters. It's characterized by its circular shape, resembling a stack of pancakes. This distinctive appearance is the result of a complex process involving cold temperatures, wind, and waves. When the water's surface begins to freeze, the wind and waves disrupt the initial ice formation, causing the ice crystals to collide and merge into rounded disks. Interestingly, pancake ice is not merely a curious natural phenomenon, it's a valuable indicator of our changing climate. As global temperatures rise, wind and wave patterns are altered, influencing the formation and behavior of pancake ice. Additionally, the reduction of sea ice due to warming oceans can create more open water areas where pancake ice can develop. This shift in ice conditions has implications for marine ecosystems, as pancake ice provides crucial habitat for various organisms. Climate variations are essential drivers of evolution. A stable climate could lead to a decline in species diversity as organisms are unable to adapt to changing conditions. Many ecosystems rely on seasonal changes and climatic fluctuations. A flatline climate would disrupt these delicate balances, leading to ecosystem collapse. Predictable weather patterns are essential for agriculture. However, a complete lack of variation could create new challenges for farmers, as pests and diseases might become more prevalent. Paradoxically, a lack of climate variability could increase the likelihood of extreme weather events. This is because climate systems are complex and interconnected, and any disruption to their normal patterns can lead to unexpected consequences. It's important to note that Earth's climate has never been truly flatline. It has undergone significant changes throughout history, driven by factors such as variations in solar radiation, volcanic activity, and, more recently, human activities. Metamorphism, a geological process that changes the structure or mineral content of a rock by heat and pressure. Polymorphism, the ability of a substance to exist in multiple crystal structures. Imitation is the sincerest form of flattery. This classic saying suggests that when someone copies or mimics another person's actions, words, or style, it's often seen as a compliment. It implies that the imitator admires the original person so much that they want to be like them. The relationship between originality and peace theories is complex. Some peace theories, such as those focused on conflict resolution or reconciliation, value originality in finding new approaches to address conflict. Other theories, like those focused on justice or human rights, may prioritize established frameworks and principles. Ergonomic energy expenditure refers to the amount of energy a person uses while performing tasks in a work environment that has been designed to minimize physical and mental strain. It's a key metric in ergonomics, as it helps to identify tasks that are excessively demanding and contribute to worker fatigue, discomfort, and potential injuries. We can explore the fascinating relationship between ergonomics and energy. Ergonomic design can be optimized to minimize energy consumption while maintaining comfort and productivity. For instance, using low-power components in ergonomic products or designing workspaces that maximize natural light and ventilation can reduce energy usage without sacrificing well-being. Additionally, we can investigate how our physical environment influences our energy levels. Factors like posture, workspace layout, and equipment design can impact our energy, focus, and overall performance. Understanding these connections can lead to improvements in workplaces, healthcare settings, and even athletic performance. Finally, we can examine the market for energy-efficient ergonomic products. Urban morphology and energy efficiency. This is a valid connection. Urban morphology refers to the physical form and structure of a city. It includes factors like building density, street layout, and land use patterns. These elements significantly impact energy consumption. For example, compact cities with mixed-use zoning tend to have lower energy consumption than sprawling suburbs. Energy systems and harmonization. This could refer to the integration and balance of different energy sources and systems. For instance, harmonizing renewable energy sources with traditional power plants to create a stable and efficient energy grid. Energy consumption patterns. This might involve analyzing energy consumption data to identify recurring patterns or trends. While not directly related to morphology and harmonies, it's possible to find underlying structures or harmonies in consumption data. Transmission lines. High voltage power lines that carry electricity over long distances. Substations. These facilities reduce voltage for distribution. Distribution lines. Lower voltage lines that deliver electricity to homes, businesses, and industries. Body and mind are interconnected. Our physical body and our cognitive processes are deeply intertwined. Our sensory experiences, motor actions, and bodily states influence our thinking, feeling, and decision-making. Grounded cognition. Abstract concepts are grounded in our bodily experiences. For example, understanding the concept of up is linked to our physical experience of standing upright. Situated cognition. Cognition occurs in a specific context and is influenced by the environment. We think and learn differently in different situations. Distributed cognition. Cognition is not confined to the individual brain but is distributed across the body, environment, and tools. For instance, using a calculator can extend our cognitive abilities. A just transition to a low-carbon economy requires careful attention to those affected by the shift. Workers, in particular, need support as industries change and new job opportunities emerge. Ensuring their safety and security is paramount. The process involves retraining workers for emerging green jobs, offering financial assistance during career changes, and guaranteeing safe working conditions in new industries. Beyond individual workers, the transition must also safeguard communities. This includes bolstering local economies, improving infrastructure, and involving residents in the planning process. Crucially, protecting sensitive data related to workers and the transition is essential. Implementing robust cybersecurity measures and training workers to prevent cyber threats are crucial. Ecocriticism is an interdisciplinary approach that examines the relationship between literature and the physical environment. It investigates how literature represents and constructs nature, and how it reflects and influences environmental attitudes and values. Phonetics, phonology, and syntax semantics represent fundamentally different levels of language structure, and treating them as equivalent would be a significant oversimplification. Phonetics, phonology deal with the physical and acoustic aspects of language, while syntax semantics deal with abstract mental representations. Phonetics, phonology focus on individual sounds and their combinations, while syntax semantics focus on words, phrases, and sentences. Phonetics, phonology are primarily concerned with the sound system, while syntax semantics directly relate to the meaning of language. While there are interactions between these levels, e.g. phonological factors can influence syntactic choices, they are distinct components of language. Treating them as equivalent would ignore the complexity and richness of human language. Synoptic morphology is a term used in various scientific fields to describe the overall form or structure of something, often in relation to its larger context. While it doesn't refer to a specific, standardized methodology, it generally implies a broad, comprehensive examination of a subject's morphological characteristics. Inflation during peacetime, this is a common economic phenomenon. After periods of war, economies often experience a surge in economic activity, leading to inflation. The psychological impact of peace on economic behavior, this is a more speculative area. Some might argue that a prolonged period of peace can lead to increased consumer confidence and spending, potentially contributing to inflationary pressures. A metaphorical or conceptual link between peace and economic growth, this is a broad and philosophical interpretation. It could suggest that a peaceful society is more conducive to economic prosperity, which might, in turn, lead to inflationary trends. Severe nuclear accidents can disrupt economies, leading to supply chain disruptions, increased costs, and potentially inflationary effects. The nuclear power industry is a significant energy provider. If there were widespread issues with nuclear power plants due to radiation concerns, it could impact energy costs, influencing overall inflation rates. A prolonged period of peace often correlates with economic stability, which can contribute to controlled inflation or even deflationary pressures. Peace fosters a positive investment climate, leading to economic growth and potential inflationary pressures if unchecked. An investment climate refers to the overall economic, political, and social conditions within a country or region that influence the attractiveness of investment. It's essentially the business environment that investors consider when deciding where to allocate their capital. While many countries strive to improve their investment climates, challenges such as economic volatility, geopolitical risks, and technological disruptions can pose obstacles. However, these challenges also present opportunities for innovative solutions and policy reforms. Contrary to the misconception of rising prices, the cost of harnessing renewable energy sources like solar and wind power has dramatically decreased in recent years. This downward trend is a result of several interconnected factors. Technological advancements, from increased solar panel efficiency to refined wind turbine designs, have made renewable energy production more cost-effective. Moreover, the expanding scale of renewable energy projects has led to economies of scale, driving down production and installation costs. Government support, such as subsidies and incentives, has played a crucial role in accelerating the growth of the renewable energy industry, which in turn has fostered competition and further price reductions. The most common method involves constructing a dam to create a reservoir. Water is released from the reservoir, passing through turbines that spin and generate electricity. This process is remarkably efficient and produces a consistent power output. Desalination, the process of removing salt from seawater to produce fresh water, is energy intensive. This high energy consumption is a significant hurdle in expanding desalination to meet growing water demands, especially in arid regions. Reverse osmosis (RO) has become a cornerstone in desalination and water purification, but ongoing research and development aim to enhance its efficiency and effectiveness. Energy recovery is a critical component of optimizing reverse osmosis (RO) desalination processes. The high-pressure feed water used in RO contains significant energy that can be recovered and reused. Energy recovery devices (ERDs) are employed to capture this energy. These devices, primarily pressure exchangers, operate on the principle of transferring energy from the high-pressure brine stream to the incoming feed water. This recovered energy substantially reduces the energy required to pump feed water to the high pressure needed for the RO process. ERDs can reduce energy consumption by up to 60%. Lower energy consumption translates to lower operating expenses. Decreased energy usage contributes to a smaller carbon footprint. While technology has made significant strides in ERD efficiency, ongoing research focuses on improving their performance, durability, and cost-effectiveness. Additionally, exploring alternative energy recovery methods is an area of active development. Regeneration is a critical process to extend the lifespan of activated carbon. When carbon becomes saturated with adsorbed contaminants, its effectiveness diminishes. To restore its adsorptive capacity, it undergoes a thermal treatment. This process typically involves heating the spent carbon to high temperatures, often in the presence of steam. The intense heat vaporizes the trapped contaminants, effectively cleaning the carbon's porous structure. Subsequent cooling prepares the regenerated carbon for reuse. While regeneration offers economic and environmental benefits, it's not without its challenges. The high energy demands of the process and the inevitable loss of some carbon during treatment are key considerations. Additionally, proper management of the released contaminants is essential to prevent environmental pollution. Despite these complexities, regenerating activated carbon remains a preferred approach to minimizing waste and preserving this valuable resource. Thermal regeneration, the most common method, involving high-temperature heating to vaporize contaminants. Steam activation, using steam in conjunction with heat for enhanced contaminant removal. Chemical regeneration, employing specific chemicals to dissolve or react with adsorbed substances. Electrochemical regeneration, utilizing electrical currents to remove contaminants. So, let's connect that paper to rocket launch data. In a nutshell, using algebraic morphology to analyze rocket launch data could help us better understand the structure and behavior of the rocket's exhaust plume. By extracting key features like shape, size, and dispersion, we could potentially optimize the design of the rocket's engine and fuel system for maximum efficiency and performance. By applying these image processing techniques to visual data of the exhaust plume, you can indeed extract crucial information about its structure and behavior. Understanding the plume's shape and size can inform decisions about nozzle geometry, combustion chamber dimensions, and propellant mixture. Analyzing the plume's dispersion patterns can help identify areas of fuel wastage and suggest refinements to the fuel injection system. Studying the plume's composition can help minimize harmful emissions. Ensuring high-quality, consistent image data is essential for accurate analysis. Noise reduction and image enhancement techniques may be necessary to improve feature extraction. Selecting appropriate morphological operators for specific features is crucial. Correlating the extracted features with rocket performance requires domain expertise. While rockets have traditionally been seen as having a minimal impact on climate compared to other human activities, this perspective is changing as the frequency of launches increases. Rocket launches emit a variety of substances, including water vapor, carbon dioxide, and black carbon, into the atmosphere. While the overall quantity is currently small compared to other sources, the composition of rocket exhaust and the altitude at which it's released can have a disproportionate effect on climate. As the space industry grows, addressing the environmental implications of rocket launches will become increasingly important. While the current impact might be relatively small, the cumulative effects of frequent launches and the potential for technological advancements in rocket propulsion warrant careful monitoring and research. Structural integrity, examining the rocket's performance under varying conditions can help develop theories about structural stress and potential failure points, leading to improved designs. Stage separation, studying the separation of rocket stages can contribute to theories about optimal staging strategies and the dynamics involved in such maneuvers. Pure expectations theory, This theory suggests that the long-term interest rate is simply the average of expected future short-term interest rates. Liquidity preference theory. This theory posits that investors demand a premium for holding longer-term bonds due to the reduced liquidity compared to short-term bonds. Market segmentation theory. This theory assumes that different bond markets short-term, medium-term, long-term are segmented and influenced by different investor groups with distinct preferences. Partition is the division of a territory into separate, independent states or autonomous regions. It often occurs when deep-seated ethnic, religious, or linguistic differences exist within a country, making coexistence challenging. These divisions can be exacerbated by geographic factors, historical grievances, or power imbalances. The partition of India into India and Pakistan in 1947 is a prime example of this, driven by religious differences between Hindus and Muslims. Secession, on the other hand, involves a portion of a state breaking away to form a new, independent country. This typically happens when there's a strong sense of national identity within a region, coupled with feelings of oppression or neglect by the central government. Economic disparities between the region and the rest of the country can also fuel secessionist movements. The secession of South Sudan from Sudan is a recent example of this process. The division of populations and resources, coupled with the creation of new borders, can exacerbate tensions and create fertile ground for conflict. Model partitioning and succession in the cloud refers to the strategies of breaking down large machine learning models into smaller, manageable components and subsequently replacing or updating these models with newer, improved versions. Model partitioning involves dividing a massive model into smaller parts to distribute it across multiple cloud resources. This enhances processing speed, reduces costs, improves fault tolerance, and strengthens data privacy. For instance, a language model might be divided into sections handling different language aspects or distributed across multiple servers. Model succession is the process of continually updating or replacing a model with newer versions. Cloud platforms facilitate this by enabling continuous training, model versioning, A/B testing, and automated deployment. This ensures models remain effective and adapt to changing data and requirements. For example, a recommendation engine might be refined over time based on user behavior, with multiple versions tested before deployment. Manual data preparation. This could refer to the process of manually creating or modifying data structures which might resemble tuples before feeding them into cloud-based algorithms. For instance, in machine learning, you might manually create training data tuples for a model. Manual tuple manipulation in cloud algorithms. This is unlikely, as cloud algorithms typically operate on data automatically without human intervention at the tuple level. However, there might be specific scenarios where human-in-the-loop systems require manual tuple manipulation, but these would be exceptions rather than the norm. Cloud image processing is the practice of using remote computer systems, or the cloud, to manipulate and analyze digital images. Instead of relying on local hardware, businesses and individuals can tap into vast computing resources to handle tasks like resizing, cropping, and enhancing images. This approach offers several advantages. First, it's incredibly scalable, meaning it can handle a small number of images or millions with equal ease. Second, it's cost-effective as you only pay for the computing power used. Third, it's fast due to access to high-performance hardware. And finally, it allows for global reach, processing images from anywhere in the world. Cloud image processing has a wide range of applications. It can be used to optimize images for websites and mobile apps, identify objects or faces within pictures, edit photos, analyze medical images for diagnosis, study satellite and aerial imagery for land use or disaster response, and even monitor security footage. Cloud images play a critical role in understanding Earth's energy balance. This delicate equilibrium involves the incoming energy from the sun and the outgoing energy radiated back into space. Clouds significantly impact this balance. Some cloud types reflect sunlight back into space, cooling the planet, while others trap heat, warming it. Ultimately, these insights help us refine climate models and predict how changes in cloud cover might affect global temperatures. It's a complex interplay, but cloud images provide essential data for unraveling this puzzle. The exact mechanisms of cloud formation and the processes leading to precipitation are still being refined. The complex relationship between clouds and climate change is not fully understood. The detailed processes occurring within clouds, such as ice crystal formation and droplet growth, are areas of ongoing research. Accurately representing clouds in climate models remains a challenge. How do tiny water droplets in clouds coalesce into larger raindrops or snowflakes? How will changes in cloud cover affect global temperatures and precipitation patterns? How do aerosols, tiny particles in the atmosphere, influence cloud formation and properties? How can we improve our ability to simulate cloud processes and their impact on weather and climate? Solar radiation modification (SRM) is a proposed method to counteract global warming. It involves altering Earth's climate system to reflect more sunlight back into space, thereby cooling the planet. This could be achieved by introducing reflective particles into the stratosphere or by increasing the reflectivity of clouds. While SRM presents a potential short-term solution to rising temperatures, it's a highly controversial approach. The primary concern is the lack of understanding about its potential side effects. Altering the Earth's delicate climate balance could lead to unforeseen consequences for weather patterns, precipitation, and ecosystems. Additionally, the governance of such a complex and global undertaking poses significant challenges. It's crucial to emphasize that SRM is not a substitute for reducing greenhouse gas emissions. Addressing the root cause of climate change through emissions cuts remains the most sustainable and effective long-term strategy. Agricultural practices refer to the methods and techniques employed in farming to cultivate and harvest crops and raise livestock. These practices can range from traditional, low-input methods to highly mechanized, technology-driven systems. Agroforestry is a farming method that incorporates trees into agricultural systems. These trees offer various benefits such as enhancing soil quality, preventing erosion, providing shade, and generating additional income through timber or fruit production. Multiple cropping, on the other hand, involves growing 2 or more crops simultaneously on the same land. This practice can increase overall yield, reduce the risk of total crop failure due to pests or weather, and improve soil health. Both agroforestry and multiple cropping are considered sustainable agricultural practices with potential to address environmental, economic, and social challenges faced by farmers. However, they require careful planning, specific knowledge, and often initial investments. Market efficiency posits that a free market, without external interference, will allocate resources optimally. This means goods and services will be produced at the lowest possible cost and in quantities that maximize consumer satisfaction. Emissions trading attempts to apply this principle to pollution. By creating a market for pollution permits, it introduces a price mechanism for pollution. This price incentivizes polluters to reduce emissions in the most cost-effective manner. Permit allocation. A government sets a cap on total emissions allowed within a specific geographic area or sector. Permits representing the right to emit a specific amount of pollution are then distributed to polluters. At first glance, peace and the halting problem appear to be worlds apart. One is a complex social and political goal, while the other is a fundamental limitation in computer science. Yet, there are intriguing parallels between them. The halting problem is a famous puzzle in computer science. It asks, given a computer program and its input, can we always predict whether the program will eventually finish running or if it will keep going forever? Surprisingly, mathematicians have proven that there's no general rule to answer this question for all possible programs. Just as it's impossible to definitively predict if a program will ever stop running, it's equally challenging to forecast when or where conflicts will erupt. Both involve intricate systems with countless interconnected factors. Additionally, conflicts that seem to drag on indefinitely can be likened to computer programs stuck in endless loops. Regression discontinuity analysis (RDD) is a statistical method used to assess the impact of an intervention. It's particularly useful when there's a clear cut-off point determining who receives the intervention. Imagine a peacekeeping mission is sent to a region when violence crosses a specific threshold. RDD can compare areas just above and below this threshold to measure the mission's impact on reducing violence. Similarly, it can evaluate the effectiveness of early warning systems or peacebuilding programs targeted at communities with specific characteristics. The strength of RDD lies in its ability to establish a causal relationship between the intervention and its outcome. By comparing similar groups on either side of the cutoff, it helps to reduce bias. However, challenges like data availability and ensuring the cutoff accurately reflects the underlying situation need to be carefully considered. Pressure distribution on flat surfaces, hydrostatics, fluid mechanics. Friction between flat surfaces. Diffraction gratings. Thin film interference. Electric field lines near flat conductors. Capacitance of parallel plate capacitors. Magnetic fields produced by current carrying flat conductors. Heat conduction through flat surfaces. Radiation from flat surfaces, blackbody radiation. Particle behavior on flat potential surfaces. Quantum Hall effect related to electrons on a flat surface. Thin films and coatings. Crystallography, flat crystal planes. Plate tectonics, large-scale flat plates. Topography and geomorphology, flat landforms. While there's no distinct, standalone cloud logic and reasoning theory, the principles of logic and reasoning are fundamentally connected to cloud computing. Essentially, it's about applying logical thinking to solve problems and capitalize on opportunities within cloud environments. This involves using logic to manage and analyze vast amounts of cloud data, ensuring security and trust through formal reasoning, coordinating and orchestrating cloud services efficiently, and optimizing resource allocation. Key theoretical underpinnings include propositional and predicate logic for formal reasoning, modal logic for handling knowledge and belief, fuzzy logic for dealing with uncertainty, probabilistic logic for combining logic and probability, and ontologies for shared understanding. However, applying logic to the immense scale of cloud computing presents challenges such as efficiency, handling uncertainty, and ensuring transparency. Despite these hurdles, the potential benefits of using logic and reasoning in the cloud are substantial, promising optimized resource utilization, enhanced security, and improved service management. One interpretation is to identify core concepts of cloud computing, such as scalability, elasticity, and virtualization, and express them as fundamental truths or axioms. This would enable the creation of a formal logical system to reason about cloud systems, potentially aiding in tasks like verifying cloud architectures or managing cloud resources automatically. Another perspective focuses on leveraging cloud infrastructure to distribute and accelerate logical reasoning tasks. By harnessing the vast computational power and storage capabilities of the cloud, complex logical problems could be tackled more efficiently. This approach could find applications in areas like fraud detection, natural language understanding, and knowledge management. Beyond these practical applications, the concept also invites philosophical contemplation. The cloud can be viewed as a metaphor for the mind, with axioms representing fundamental beliefs. Exploring this analogy could contribute to fields like artificial intelligence and cognitive science. However, challenges abound. Clearly defining the essence of cloud logic is crucial. Transforming intuitive cloud concepts into precise axioms can be difficult. Ensuring that cloud-based reasoning systems can handle massive datasets and complex problems efficiently is essential. The integration of quantum and classical computing within a cloud environment is a complex but essential step towards realizing the full potential of quantum computing. This hybrid model leverages the strengths of both systems, addressing the limitations of each while maximizing computational power. Domain expertise: collaborate closely with domain experts, climatologists, and researchers. Their insights are crucial for designing an ontology that accurately captures climate-related concepts, variables, and interdependencies. Dynamic modeling: climate data evolves over time due to new observations, research findings, and changing environmental conditions. An ontology should be designed to accommodate these updates seamlessly. Consider using a versioning system to track changes. Granularity: strike a balance between granularity and generality. Too fine-grained ontologies may struggle to adapt to new data, while overly general ones might lack specificity. Hierarchical structures can help manage granularity. Modularity: divide the ontology into smaller modules or sub-ontologies. This modularity allows for easier updates and maintenance. When new data emerges, you can focus on updating specific modules rather than the entire ontology. Linked data and RDF: convert climate data, e.g. from NOAA, into the Resource Description Framework (RDF) format. This enables data integration and interlinking with other databases. By publishing it as linked data, researchers can access and query it directly via the web using Sparkle 1. Semantic annotations: annotate data instances with semantic metadata. This enhances the ontology's ability to adapt by providing context and meaning. For example, annotating temperature data with location, time, and measurement units. Temporal and spatial aspects: climate data often involves temporal time-related and spatial location-related dimensions. Ensure the ontology captures these aspects effectively. Consider using time ontologies, e.g. all-time and geospatial ontologies. The Climate Analysis Ontology, or CAO, is a sophisticated tool designed to organize and interpret the vast and complex realm of climate data. It serves as a foundation for understanding various climate data sets, their properties, and the intricate processes involved in their analysis. This intricate framework is essential for a multitude of climate-related endeavors. Remote sensing experts rely on the CAO to organize and analyze satellite imagery for climate studies. Climate modelers utilize it to structure input and output data. Those assessing the impact of climate change on various systems also benefit from the CAO's clear organization. Moreover, it ensures the long-term accessibility and usability of climate data through effective archiving and preservation. Despite its significance, the CAO faces challenges. Maintaining consistency with other climate ontologies, accommodating the ever-increasing volume and complexity of climate data, and adapting to the dynamic nature of climate science are ongoing hurdles. Future advancements should focus on integrating the CAO with other relevant ontologies. Ontology sensitivity refers to how well an ontology adapts and responds to its surroundings. A sensitive ontology is like a chameleon, changing to fit its environment. It must be specific to its intended use, understanding cultural nuances, and able to handle changing information. The ontology must also be able to handle imperfect data, protect privacy, and adapt to new information. Ultimately, a sensitive ontology is one that can flexibly handle the real world, accommodating changes, diverse perspectives, and user needs. In political science or social studies, aggregated fragile peace could be defined as a state of relative calmness between various factions or groups, which is maintained through a combination of formal institutions and informal agreements. It is described as aggregated because it involves the cooperation and coordination of multiple actors, and as fragile because it can be easily disrupted by any one actor or external factor. The term peace in this context refers to the absence of open conflict or violence, but does not necessarily imply a deep or lasting peace. Alignment algorithms. These algorithms aim to find correspondences between elements of different ontologies, e.g. classes, properties, individuals. Ontology mapping. This involves creating explicit mappings between ontologies, often using alignment algorithms as a foundation. Ontology merging. This combines multiple ontologies into a single, unified ontology. While not directly a comparison, it requires significant comparison and alignment steps. Ontology matching, similar to alignment, but often focuses on finding equivalent or similar concepts across ontologies. The Fragile States Index is a yearly assessment that ranks countries based on their likelihood of experiencing conflict or government collapse. It's created by the Fund for Peace. To determine a country's ranking, the index examines 12 factors, such as the strength of its security forces, the level of corruption, economic health, and the state of its legal system. Essentially, it measures a nation's ability to handle internal and external pressures. A higher score indicates a greater risk of instability. This index is crucial for policymakers, aid organizations, investors, and the general public. It helps identify potential crisis areas, allocate resources effectively, assess investment risks, and understand global challenges. While the index doesn't predict exact conflict timing, it highlights countries vulnerable to collapse and can be a valuable tool for early warning and prevention efforts. Do commerce is an old idea suggesting that trade softens societies, making them less likely to fight. The thinking is that when countries trade, they become interconnected, and this interdependence makes war less appealing. It's like two people who do business together being less likely to quarrel because they have a shared interest in keeping things peaceful. Peace economics is a broader field that studies how economic factors influence peace and conflict. It looks at things like economic growth, inequality, resource management, and arms trade to understand why countries fight or cooperate. While Do Commerce focuses specifically on trade as a peacemaker, peace economics takes a wider view of economic factors that contribute to peace. Both ideas are connected. Do Commerce is a part of peace economics, but peace economics offers a more complete picture by considering many other economic elements that impact peace. However, it's important to remember that trade isn't a magic solution for peace. Always peace is a strategy where a country consistently chooses peaceful relations with its neighbors, regardless of their actions. This approach prioritizes cooperation but risks being exploited. Always war is a purely aggressive strategy. A country following this approach consistently chooses conflict to maximize gains. While potentially rewarding in the short term, this strategy often leads to long-term losses due to retaliation. Tit for tat is a more complex strategy that begins with cooperation but then mirrors the opponent's previous move. This means a country cooperates if the neighbor cooperates but resorts to war if attacked. It's a balance between cooperation and retaliation. Provocable nice guy is a strategy that starts with peace but responds with war if attacked. The aim is to deter aggression while maintaining a peaceful image. However, this approach can escalate conflicts if misjudged. Peace war games are simplified models used to study the complexities of international relations. Essentially, they simulate interactions between countries, where the primary choices are to pursue peace or war. These models are designed to understand the factors that influence cooperation or conflict between nations. In a peace war game, countries make repeated decisions, and the outcomes of these choices are measured in terms of points or other rewards. For instance, mutual cooperation, both countries choosing peace, typically results in a reward for both, representing the benefits of peace. Conversely, one country choosing war while the other pursues peace generally leads to a loss for the peaceful country and a gain for the aggressor. By analyzing the outcomes of these strategies in different scenarios, researchers can gain insights into the conditions that foster cooperation or conflict. While these models are simplified representations of reality, they offer valuable tools for understanding the dynamics of international relations and informing diplomatic strategies. First, Galtung's conflict triangle delves into the core components of a conflict. It posits that a conflict is a complex interplay of attitudes, behaviors, and underlying structures. Attitudes encompass the beliefs, values, and perceptions held by those involved, shaping their worldview of the conflict. Behaviors are the actions taken, both overt and covert, which manifest the conflict. Contradictions, or structures, are the root causes, such as inequality or resource scarcity, that fuel the conflict's existence. Galtung emphasized the interconnectedness of these elements, asserting that lasting peace requires addressing all three. Secondly, the drama triangle focuses on the roles individuals adopt within a conflict. This psychological model identifies the victim as the powerless figure, the persecutor as the blame-shifting aggressor, and the rescuer as the well-intentioned but often enabling character. It highlights how people can become trapped in destructive patterns, and escaping these roles is crucial for conflict resolution. Celestial coordinates, defining the position of celestial objects on the celestial sphere using right ascension analogous to longitude and declination analogous to latitude. Ephemeris calculations, predicting the positions of celestial bodies over time, crucial for navigation and timekeeping. Geodetic surveys, mapping and surveying land, determining boundaries, and constructing infrastructure. Geodetic datum, defining a reference frame for geodetic measurements, including the prime meridian, the 0 point for longitude. Unpredictability of clocks, mechanical clocks of the time were unreliable, making it difficult to accurately measure the time difference between a ship's location and a known reference point like Greenwich, England. Climate appeasement is a term used to describe the act of making concessions to address climate change without taking sufficiently strong or immediate action to mitigate its effects. Governments or organizations might set emissions reduction goals that are not ambitious enough to prevent catastrophic climate change. Procrastinating on implementing necessary policies or regulations, allowing emissions to continue rising while claiming to address the issue. Making decisions that favor short-term economic growth over long-term environmental sustainability. Greenwashing engages in misleading marketing or public relations efforts to portray an organization as environmentally friendly while continuing harmful practices. Some critics argue that climate appeasement is a dangerous strategy that could lead to irreversible consequences. They believe that the climate crisis demands urgent and drastic action, and that incremental changes are not enough. On the other hand, some argue that climate appeasement is a necessary approach to balance environmental concerns with economic realities. They believe that it is important to avoid policies that would cause significant harm to businesses and jobs. The Global Peace Index (GPI) is an annual report that ranks countries based on their level of peacefulness. Produced by the Institute for Economics and Peace, it evaluates 163 independent states and territories, covering nearly the entire global population. The index considers a wide range of factors, such as the level of crime, the extent of ongoing domestic and international conflicts, and the degree of militarization. By analyzing these elements, the GPI provides a comprehensive picture of a country's overall peacefulness. The GPI is a valuable tool for policymakers, businesses, and individuals to understand global trends in peace and conflict. It helps identify regions at risk and highlights the economic benefits of peace. While the world has seen some improvements in certain areas, the overall trend in recent years has been a decline in global peacefulness. Non-linguistic peace refers to the state of harmony and tranquility that exists independently of language. It's a concept that explores the idea that peace can be experienced and cultivated beyond the realm of verbal communication. Technology may not always be able to keep up with creative visions. Pushing boundaries can sometimes alienate listeners. Striking the right balance between experimental and accessible sounds is crucial. Stepwise motion in music refers to the movement of a melody by the smallest possible intervals, which are the major and minor seconds. Essentially, it's like walking up or down a staircase, one step at a time. An attribution morphism could map causal relationships between systems. For example, in a complex system, it could map how changes in one component affect other components. Moral syncretism is the process of combining different moral systems or beliefs to create a new, often more inclusive and comprehensive ethical framework. It's about finding common ground between different cultures, religions, or philosophies. The cross-linguistics of image semantics and cloud semantics is becoming increasingly important due to the growing volume of image data processed in the cloud. Real climate refers to the scientific consensus on climate change, it's happening, it's primarily human-caused, and its impacts are increasingly severe. This is a foundation upon which any effective climate action must be built. The resource curse is a paradoxical economic phenomenon where countries rich in natural resources often experience poorer economic outcomes compared to those with fewer resources. It's counterintuitive because one might expect abundant resources to be a significant advantage. Several factors contribute to this paradox. First, the sudden influx of wealth from resource exports can lead to a strengthening of the country's currency, making its manufactured goods less competitive on the global market. Second, when a government derives a substantial portion of its revenue from resource exports, it becomes less reliant on taxes and, consequently, less accountable to its citizens. This can foster corruption and inefficient spending. Furthermore, the potential for immense wealth from resource exploitation can divert attention and resources away from other productive economic sectors. Individuals and businesses might focus on capturing a share of resource revenues rather than building sustainable industries. Political instability is another common consequence. Competition for control over valuable resources can lead to conflict and hinder economic development. Canonical correlation analysis (CCA) is a powerful statistical technique used in climate science to uncover relationships between two sets of variables. It's particularly useful when dealing with complex data sets with many interrelated factors. CCA can help identify teleconnections, which are long-distance relationships between climate phenomena. For example, it can reveal how changes in sea surface temperature in one region influence weather patterns in another. A classic example is using CCA to study the relationship between El Niño Southern Oscillation (ENSO) and rainfall patterns across different regions. By identifying the canonical variates, researchers can understand how ENSO influences rainfall variability in specific areas. Exploring whether peace can be considered a core or fundamental value across different canonical traditions. Investigating how canonical texts have shaped and influenced peace movements or peace-building efforts. While less formal, natural languages like English, Spanish, Chinese have standardized ways canonical to represent and use numbers. Conclusion. What is a human? While the human bear-pig is primarily a comedic construct, the man-bear-pig from South Park takes on a much more serious tone. It serves as a potent and satirical allegory for the devastating effects of climate change. The man-bear-pig is a grotesque amalgamation, much like the chaotic and unpredictable nature of climate change. It's a creature born of human-induced environmental degradation, a monstrous byproduct of our disregard for the planet. By creating this monstrous hybrid, South Park effectively highlights the grave consequences of ignoring climate change. It's a stark and satirical warning about the potential outcomes of unchecked environmental damage. Bond length is essentially the distance between the centers of two bonded atoms. Imagine two atoms connected by a spring. The length of that spring represents the bond length. This distance is influenced by several factors. Firstly, the type of bond between the atoms matters. A single bond, where atoms share one pair of electrons, is typically longer than a double bond, where two pairs are shared. A triple bond, with three shared pairs, is the shortest of the three. Larger atoms have more space between their nuclei, leading to longer bond lengths. This is akin to stretching the spring between larger objects. Hybridization is a concept in chemistry that explains the bonding behavior of atoms, particularly in organic molecules. It involves the mixing of atomic orbitals to form new hybrid orbitals with different shapes and energies. These hybrid orbitals are then used to form chemical bonds. Traditional atomic orbitals often fail to predict the observed shapes of molecules. In molecules like methane CH4, all CH bonds are identical, suggesting that the carbon atom uses equivalent orbitals for bonding. Hybridization helps explain this. Hybridization is a mathematical concept, not a physical process. Hybrid orbitals have different shapes and energies than the original atomic orbitals. Hybridization is used in conjunction with valence bond theory to explain bonding. The climate peace nexus refers to the intricate relationship between climate change and conflict. While the exact nature of this relationship is complex and often debated, it's undeniable that climate change can act as a threat multiplier, exacerbating existing tensions and vulnerabilities. Understanding complex causal relationships is a cornerstone of many disciplines, from social sciences to natural sciences. These relationships often involve multiple interconnected factors influencing an outcome, making it challenging to isolate direct cause and effect. Critical realism is a philosophical approach that posits a distinction between the real world and the observable world. The real world exists independently of human perception, while the observable world is our constructed understanding of it. This distinction is crucial because it allows for the existence of underlying structures and mechanisms that produce observable events, even if these structures are not directly observable. Stratification recognizes multiple layers of reality, from the most abstract structures to concrete events. Stratification analysis is a statistical method used to assess the association between an exposure variable and an outcome variable, while controlling for the effects of one or more confounding variables. It involves dividing the population into subgroup strata based on the values of the confounding variables, and then analyzing the association between the exposure and outcome variables within each stratum. To account for the potential influence of age, we can stratify the data by age groups, e.g. young adults, middle-aged adults, older adults. By examining the relationship between education and income within each age group, we can determine if the original positive correlation holds true when controlling for age. If the positive correlation persists across all age groups, we can be more confident that education level is indeed linked to income, even after considering the effect of age. On the other hand, if the correlation differs significantly between age groups, it suggests that age is a confounding factor influencing the original relationship. Dehumanization is the process of perceiving another person or group as less than human. It's a psychological mechanism that allows individuals to justify harmful actions against others. When we view someone as less than human, our moral inhibitions are lowered, making it easier to inflict pain or harm. Climate distance is a term used to quantify the difference between the climates of two locations. It's a way to measure how similar or dissimilar two places are in terms of their weather patterns. A practical application of climate distance is the climate distance mapper. This tool helps land managers match seed sources with restoration sites based on climatic similarity. By ensuring that seeds are sourced from areas with similar climates, the chances of successful plant establishment are increased. Advanced interdependent systems are intricate networks where components are deeply connected and influence each other's behavior in complex ways. These systems are characterized by their complexity, where countless elements interact in a multitude of ways, leading to unpredictable outcomes. Unlike simple systems where outputs are directly proportional to inputs, these systems exhibit nonlinearity, meaning small changes can have disproportionate effects. One fascinating aspect of these systems is the emergence of new properties from the interactions of their components. These emergent properties are not inherent in the individual parts but arise from their collective behavior. Additionally, these systems are dynamic and adaptive, constantly influenced by feedback loops where outputs impact inputs, creating a continuous cycle of adjustment. Citations. References: Benner, A.K. and Roth, D. 2024. World in the Making, on the Global Visual Politics of Climate Engineering. Review of International Studies, 51, 79-106. Volker, O. 2024. Water, Clouds, Rocks, Non-Human Temporalities and Adalbert Stifter's Poetics of Nature. In German language nature writing from 18th century to the present, Controversies, Positions, Perspectives pages 145-167. Chem, Springer Nature Switzerland. Nicholas, Q. and Booz, W.R. 2024. Understanding the Spatiotemporal Variability of Tropical Orographic Rainfall Using Convective Plume Buoyancy. Journal of Climate, 37-5, 1737-1757. Boog, H. Benjaminson, T. A. Gilmore, E. A. and Hendricks, C. S. 2023. Climate-Driven Risks to Peace Over the 21st Century. Climate Risk Management, 39, 100,471. Wang, Tianhong, et al. Temperature Shapes Language Sonority, Revalidation from a Large Data Set. PNAS Nexus 2.12 2023, PGAD 384. Sharifai, A. C. Manon, D. Lee, C. Y. Reyes, S. R. Katramas, T. Yusol, J. C. and Islam, M. 2021. Climate-Induced Stressors to Peace, a Review of Recent Literature. Environmental Research Letters, 16-7, 073006. Nicholson, C. 2021. Towards Climate-Resilient Peace, an Intersectional and Degrowth Approach. Sustainability Science, 16-4, 1147-1158. Hart, J. N. and Skefran, J. 2019. Environmental Peacebuilding and Climate Change, Peace and Conflict Studies at the Edge of Transformation. Policy Brief, 68, 1-20. Gleditsk, N. P. Nordkvel, J. N. Strand, H. 2014. Peace Research, just the study of war. Journal of Peace Research, 51 to 145 to 158. De Rivera, J. Karine, R. and Olson, N. 2007. The Emotional Climate of Nations and Their Culture of Peace. Journal of Social Issues, 63 to 255 to 271. Bazarova, T.A. And the time now is not different, but still the present, the problem of the ratification of the Adrianople Peace Treaty 1713. Vestnik Volgogradskogo Gosударственного Universiteta. Seria 4. Istoria. Region of Vidny. Международные отношения, 15 to 26.
Shadow in the woods tonight, claws like knives in the pale moonlight. It's not man, it's not beast, it's not a dream. Teeth like a nightmare, stitched at the seams. You'll hear the snap, the crunch, the growl. It's coming closer, oh it's foul. Human baby, it's coming for you. But you can't undo. Human baby, it's hungry and wild. Half a monster, half denial. Footprints bigger than your fear can hold. Breath like smoke, eyes burning cold. It's not a myth, it's not a lie. It's the truth, the woods are alive and it's hunting you. Is it the end or the start of a joke? Is it a warning or just cruel hope? Half of the truth is scarier than none. When you're staring at the barrel of what you cannot run. Human baby, it's coming for you. Row escape when it's on to you. Human baby, it's savage and vile. Half a terror, half a trial. Footprints bigger than your fear can hold. Breath like smoke, eyes burning cold. It's not a myth, it's not a lie. It's the truth, the woods are alive and it's